There's a 30% chance that it'll rain tomorrow, 23% of people prefer chocolate-flavored ice cream, and 31% of people are night owls. These are all examples of probabilities, and probability tells us the likelihood of something happening. Although this might seem pretty straightforward, in the statistics community there's still a debate about how we should come up with the probability of something. In this video, we're going to learn about the two most popular schools of thought, the Frequentist and the Bayesian views of probability. Let's imagine there's a slot machine that has two outcomes, a gold coin where you win $1 and a rotten tomato where you'll lose $1. Our goal is to figure out the probability of winning. In statistics, rather than writing out the sentence probability of winning, we're going to use some notation. Here we're going to use this notation where P stands for probability and W stands for winning. So this reads as the probability of winning. This probability of winning is very useful to us because a low probability means that you'll lose more money, whereas a high probability means that you'll win more money. So let's try to figure out this probability using two approaches. In the first approach, we're going to pull the lever of the slot machine for a large number of times to collect some data. And after a certain large number, we're going to compute our probability of winning by simply calculating the number of times that we won over the total number of times that we pulled the lever. So for example, let's say we're running this experiment 100 times and that 100 is sufficiently large enough to us. Suppose that 43 of those times we won and 57 of those times we lost. We can compute the probability of winning by simply dividing 43 by the number of times we pulled, which is 100. This means that the probability of winning is 43%. This approach is called the Frequentist approach. A Frequentist is purely data-driven and assumes that if we have a large enough number of trials and that each experiment is conducted similarly, we can reliably estimate the probability of an event by simply dividing the frequency of the event by the total number of trials. There's also another view of probability, and this view is called the Bayesian approach. A Bayesian statistician would start this experiment by incorporating their subjective intuition about this slot machine. She might say, based on my experiences playing with slot machines in the past, I believe that the probability of winning is low, say around 30%. She can use her belief in addition to the data collected from a slot machine to help her compute the probability of winning. Now, what are some critiques of both approaches? Well, the Frequentist assumes an experiment is conducted similarly. However, in this view, there isn't a definition of what similar means. This is an issue because different people may have different perspectives of what similar means to them. Another critique is the large sample size. How do we know when large is large enough? Does large means 100, 1,000, or 10,000? In different settings, large can mean different things. The Bayesians also have critiques of their own. The biggest and most obvious critique is the subjectiveness of Bayesians. Different people have different opinions, so how do we figure out the best opinion? To recap, Frequentist and Bayesian views of probability are the two most popular interpretations of probability. Frequentists rely on the frequency of an event and assume that the experiment was conducted in a large number of times, whereas Bayesians combine their subjective intuition with data to come up with probability. In statistics, there isn't a one-size-fits-all approach, as different situations call for different types of methodologies and assumptions when analyzing the data. Perhaps next time you hear a statistic, you might wonder, is this a Frequentist or a Bayesian view? Hopefully this video sheds some light on that. To learn more about data science, don't forget to like and subscribe.